All right, so you know how we always talk about the history of life on Earth and you think we've got it all figured out?
Yeah.
Well, get this. A 99-million-year-old wasp
Wow.
with a Venus flytrap for an abdomen has just been discovered. Like, how cool is that?
That's incredible. Where did they find this?
I know, right? So we are diving deep into some brand new research published in BMC Biology
Oh, very cool.
on this crazy wasp.
Nice.
It's called Sirenobethylus charybdis.
Sirenobethylus charybdis.
And the goal here is to kind of understand what this tells us about the way things were way back when.
Right, yeah. It's like a little window into the past.
Totally, yeah. Okay,
Yeah.
so 99 million years old. Like, that's just mind-boggling. Where did they find this incredible fossil?
Yeah, so it was found preserved in amber
Of course.
from the Kachin region of northern Myanmar.
Myanmar, okay.
And this dates back
To the
to the mid-Cretaceous period. So you're talking dinosaurs roaming around, all sorts of crazy...
crazy insects, for sure.
And what's really fascinating is its unique hind wing vein pattern actually suggests it could belong to a whole new insect family
Whoa.
called Sirenobethylidae.
That's wild.
So like an entire new branch on the insect family tree.
From this one little wasp?
Yeah, just from this one discovery.
Yeah, I love it. Okay, so a potential new insect family from a prehistoric wasp with a flytrap butt. Okay, you've got to dig into this. The research mentions this wasp was what's called a parasitoid. What was this wasp up to? What is that?
Right, so a parasitoid is basically an insect
Okay.
whose larva develops inside another insect.
So it lays its eggs inside another insect.
Exactly.
Wow.
Yeah, and it eventually kills it. So it's not a very nice way to go.
Yeah, but effective.
Yeah, it's very effective.
And for the wasp, at least.
Yeah, got to do what you got to do.
Exactly. And the name, Sirenobethylus charybdis,
Yeah.
that's wild. Sound like something out of Greek mythology.
It is actually. It's named after Charybdis, which is the sea monster in Greek mythology that would swallow ships and regurgitate the water.
Oh, yeah.
So I guess the researchers chose that to reflect the wasp's unique abdominal structure
Oh, that's cool. I like that.
and how it captured its prey.
All right, so let's talk about this crazy fly trap. What did it actually look like?
Okay, so imagine this. You got the wasp abdomen,
Okay.
and at the end of it,
Yeah,
there are 3 flaps.
3 flaps.
And the lower one is like a paddle shape
Okay.
with about a dozen hair-like bristles on it.
So that's the fly trap.
That's the fly trap, yeah.
Oh, wow.
And what's crazy is nothing like this has ever been seen in any other insect, living or fossilized.
So this is truly unique.
It's a totally unique biological innovation, yeah.
That's amazing. A completely unique gripping mechanism. What do scientists think it was used for?
Well, the main theory is that it was used to temporarily trap small prey
Oh,
during egg laying.
Oh, so it catches it,
Exactly,
holds
yeah.
it in place, and then lays its eggs inside.
Yeah, so it probably waited with this trap open for a little tiny insect to come along.
Okay.
Maybe something that can fly or jump.
So small mobile insects, yeah?
Yeah, something like that, yeah.
Right.
And then, bam, it would snap shut.
Wow. Talk about an ambush predator.
Yeah. It's got a built-in snare.
Super cool.
Yeah, very clever.
Okay. And we touched on this earlier,
Yeah.
but it was a Koinobiont parasitoid.
Right.
That's right.
What does that mean? Remind us.
So basically this means that it probably allowed its host to continue living and growing,
Oh.
even while its larva was feeding inside.
Yikes.
Yeah, so not a fun time for the host insect.
Yeah, definitely a slow and painful death.
Probably, yeah.
Oh, wow. Okay, so the researchers used some pretty high-tech stuff to study these wasps, right?
Yeah, they did. They used something called micro-CT scanning.
Micro-CT scanning. What is that, and what did it show them?
Yeah, so micro-CT scanning, it's like a 3D X-ray.
Oh, wow.
So they were able to get these detailed 3D images of 16 female specimens.
And this really allowed them to analyze the intricate structure of that abdominal trap
Okay.
and confirm those really distinctive hind wing vein patterns.
Yeah.
That suggested a new family.
Gotcha. So they were able to really see everything without
Everything.
damaging the amber.
Yeah, it's a non-destructive way to look inside these ancient creatures.
Very cool. Okay, so big picture here. Why is this flytrap-bottomed wasp from 99 million years ago so important?
Well, I think the most significant thing here is that it reveals a predatory strategy that's unlike anything we see today.
That's wild.
So it suggests that there was a much wider range of evolutionary experiments happening in the Cretaceous period.
Yeah.
And this wasp represents a really highly specialized lineage that didn't make it.
Oh, wow.
So we're seeing a glimpse into a lost world of biological possibilities.
That's incredible.
Yeah, it's amazing.
And that's thanks to this research.
Exactly. This was done by Wu and colleagues, published in BMC Biology.
Yeah.
And you can find it with a DOI 10.1186-12915 025 021902.
Okay, so really this ancient wasp, with its bizarre adaptation, underscores the incredible diversity of life in the Cretaceous, huh?
Absolutely.
Yeah.
And I think it really makes you wonder
What
other unimaginable biological mechanisms might have existed millions of years ago
Yeah.
and are just waiting to be discovered,
Yeah.
locked away in the fossil record.
Right. Like what other cool evolutionary stuff is just waiting to be found?
Yeah, exactly. What other evolutionary dead ends or surprising successes are out there?
This is why we do what we do.
Yeah, this is what makes paleontology so cool.
I love it.